So we will start with the Hess's law calculation. So we will try different questions over here. So this one, okay, you have hydrochloric acid, okay, is going to be mixed with equal volume. So that is going to be 25 cm cube of sodium hydroxide. Initial temperature is 15. The maximum temperature was 30. You can calculate the temperature increase. Okay, it's going to be 15. So this reaction is exothermic. You can see everything is going to be negative over there. So here I want to actually calculate the enthalpy change of neutralization. HCl plus NaOH gives me NaCl plus H2O. Okay, that is going to be supposed to be the reaction, and it's balanced. Okay, according to the definition of enthalpy change of neutralization, is going to be the energy release, okay, when 1 mole of water is being formed. So here 1 mole of water is being formed. Okay, so here what I need to do is I need to still calculate. Okay, I need to still calculate for okay, for Q equals to MC delta T first. Okay, I need to do that. So the M, okay, so Yvonne, can you tell me the M, what is the M that I will use?
50.
50. We will add the 25 and 25. So 50 gram. The C is 4.18. And then the temperature change is going to be 15. Okay, please calculate for me. Okay, double check. Okay, this one's supposed to be in joules. Okay, so this one, okay, we want to actually find out, okay, what is going to be the enthalpy of neutralization here. Okay, now enthalpy of neutralization is going to be when 1 mole is being formed. So let's actually see that in this kind of situation, when you have, okay, 25 cm cube, and then when you have 4 mole per dm cube, how many moles that we have? Okay, that is important. We need to calculate. So when we calculate here, okay, number of moles is going to be C concentration, okay, times the volume divided by 1000. So you will get 100 divided by 1000. So you are talking about 0.1 mole. This is 0.1 mole. The same thing when you calculate, you will get 0.1 mole. It means we are talking about 0.1 mole. Okay, so in this case, when you calculate the energy change over here, this energy change is only for 0.1 mole. I want the enthalpy change. Enthalpy change of neutralization is actually when 1 mole, okay, of water is being formed. Okay, so if you have 0.1 mole, okay, that is going to give us negative 3135. Okay, I want for 1 mole. So what you need to do, you need to times by 10. You need to times by 10. So you will get negative 31350 joule, okay, per mole, okay, per mole. So we need to change it into kilojoule. Okay, so 1, 2, 3, 31.4, okay, kilojoule per mole, and it must be negative. Okay, so that is going to be the answer for this question. So this one is MC delta T. Okay, so this is going to be a simple equation to actually tell you, simple question to tell you how to apply Q equals to MC delta T. And then we try to apply that formula into the enthalpy change of neutralization. Is there any question for this, Benedict? Any question, Benedict? Jasmine?
No, sir.
Okay. So let's actually move on. Question number 2. Okay. So this question number 2, before I just move on, okay, I want to also talk about this related to bond breaking and bond formation. I have mentioned this earlier to you. Like for example, if I have AB plus CD to give me AC and gives me BD. Okay, so what happens is there's going to be, we call this as double displacement reaction, but it doesn't matter. What happens here is the bond between A and B is broken, the bond between C and D is broken, the bond between A and C is being formed, the bond between B and D is going to be formed. Okay, so if I actually put it, if I separate it, this is called bond breaking, and this is going to be bond formation. Now, I want you to remember this. Bond breaking, you need to have energy to break the bonds. Okay. So, Owen, you can go to toilet. You need energy to break bonds. Okay. Therefore, you need the energy from the surrounding, energy coming in. So, bond breaking is always endothermic, it's always positive. And for bond formation, okay, when you form bonds, okay, they the particles, they are moving around, they have kinetic energy, and then you want to make them to sit in one place. So where the energy goes, the energy goes to the environment as heat. The kinetic energy will be changed into heat. So this is going to be, bond formation is always negative. Please take note. So it's always negative. So if we actually put it as, okay, it's actually quite laggy. My screen, whatever things that I'm writing on the screen is actually taking time to appear. Okay, let's actually, probably I'll actually share it again. Okay, let's try whether that actually going to help. Okay, let's see whether this is going to be better. Yeah, you can see here, okay, you have the bond formation is going to be negative. So it's always exothermic because it's going to release the energy to environment. So all reactions, they have these two. So what you need to do in order to actually calculate the enthalpy change, okay, what we do is, if you have a certain value of positive, certain value of negative, we just need to add. Okay, if this is going to be number 1, this is going to be number 2, any value. So what we are going to do, we are just going to add those things. Yeah. So it means that if you have positive 50 here and you have negative 100 here, what I am going to do is 50, positive 50 plus negative 100, I am going to get negative 50. So it's going to be, overall, it's going to be exothermic. It means that we can predict, okay, we can predict whether the reaction is going to be exothermic or endothermic based on this example. Okay, if I say that this reaction is exothermic, it means it's negative. Negative means your bond formation, energy release for the bond formation is always more compared to the bond breaking. So that's why it's exothermic. If I say a particular reaction is endothermic, it means that this energy is more. Okay, so it means that, let's say I can say that the energy that is required for breaking the bond is more compared to the energy is that is released to form the bond. Therefore, it is endothermic. Okay, that is the reason behind why I told you that we will learn later. So now we actually learn about it. Okay, this one is actually about when you have a particular reaction. Okay, it always involves bond breaking and bond formation. So if, let's say, we want to actually look at this example here, they say that, okay, all reactant and products of an exothermic reaction, they are gases. Okay, they say that the reactants and products of an exothermic reaction is gas. So I think one of the reaction that I can actually remember is like something like related to nitrogen plus hydrogen, okay, to give you ammonia. All of them are gases. and I know that this is going to be exothermic also. This is one of the examples that I can remember. But they ask you which statement about this is correct. So let's actually, please actually think about what I have mentioned just now and try to answer this question. Okay, Nicholas, can you actually, Nicholas Chai, can you actually suggest a possible answer for this? Just I give you some time. Okay, please go through this. Let's actually start from the enthalpy change. Enthalpy change, negative, positive. Enthalpy change is negative, positive. Which one can you cancel out? Nicholas Chai.
BD cancel.
Yes, BD you cancel. So it's between A and C. So let's actually see which one is going to be. Do you think the products, okay, I told you just now to separate this into two. This is going to be the reactant and this is going to be the product. And I mentioned that this is going to be bond breaking and this is going to be bond formation. So if this one is negative, which one, Nicholas Chai, can you tell us which one is going to be more, bond formation or bond breaking, if this one is negative?
Bond breaking.
Bond breaking is always positive, right? So if it is more, definitely it's going to be positive.
Oh,
So it's supposed to
okay.
be, because if you want a negative answer, okay, it means this value must be more. Okay, if you want a positive answer, then this value should be more. Okay, in this case I want negative because the overall is an exothermic reaction. So of course I want this value to be way more. Like for example, I give you one example. Let's say this one is going to be 102 for example. Okay, 102 for example, and this one was only 10. So when I add these two, it's going to be negative 102 plus 10. I am going to get negative 92. I'm going to get a negative value. So it means that I must make sure that this value is more compared to bond breaking. Okay. So here the answer is going to be, if you see the total bond energy of the product, is it going to be less or more? The product should be more, okay, than the total bond energy of the reactant. Okay, that is going to be the answer. Nicholas, can you understand this?
Yes, sir.
Yeah. Okay, please actually, maybe in future when we come across more questions on this, I will explain to you. I'll come back to you on this. Okay, but I'm just introducing you about bond breaking and bond formation. Okay, if you go on for number 3. Now, this is going to be very interesting. Which expression gives you standard change of combustion of methane? How to do this? Don't actually straight away look at the equation. You will get very confused. So what you need to do is you need to write down what is enthalpy change of combustion of methane. Okay, methane, CH4, combust. When you combust, it gives you carbon dioxide and water. Write it down. Okay, this is enthalpy change of combustion. Okay, so write it down and balance the equation. So I put 2 there. And then I'm going to have 4 oxygen. Okay, so I put 2 over there. Okay, it's balanced. Okay, now I do see in this equation everything to do with formation. Okay, everything to do with formation. Now, if I want to refer things with formation, I told you I have a magic method. Okay, what is my magic method? I will tell you how the magic method will save you over here. To form CH4, the arrow will be towards to form CH4. Okay, no need to write the carbon plus hydrogen, no need. The arrow to form CH4, 1 mole of CH4. This is going to be enthalpy change of formation of CH4. Okay, now do remember to form O2. This enthalpy change of formation is 0 because you do not need to form O2. Any element, enthalpy change of formation is 0. To form carbon dioxide, okay, to form carbon dioxide, yeah, so I'll just put enthalpy change of formation of carbon dioxide. To form water, okay, but I am forming 2 moles of water. So this is going to be 2 enthalpy change of enthalpy change of water. So now, if I want to actually refer it, let's say I want to draw a diagram related to, let's say, a circle. If I put a circle over here, I want to actually make them, okay, turn it into arrows, like for example, like this, okay. This one comes over here, this one goes here, this one goes here. So how do I write it down now? Okay, clockwise equals to anti-clockwise. So clockwise, enthalpy change of formation of CH4, okay, this one plus 0, and plus enthalpy change of combustion of CH4, okay, must be equals to anti-clockwise enthalpy change of formation of carbon dioxide plus 2 enthalpy change of formation of water. Okay, this one is formation of carbon dioxide. So here, okay, I need to actually calculate what they say, which one is combustion. So for combustion, enthalpy change of combustion of CH4 is, I just rewrite over here, minus enthalpy change of formation of CH4. So you go and find out which one applies to that. So which one? Michelle V?
Yes, sir.
Which one is the answer? A, B, C, D?
D.
Yeah, you can see over here. This is one of the application of the magic methods, okay, that I taught you, okay, in the video. Okay, please actually try to practice on this. So this one, if you listen to my lesson properly, the video properly, you will notice that whenever there is formation, I like to use this method. It's faster. Yeah, it's faster. So let's actually move on. Okay, here, okay, I have certain really something to do with formation. So I think it's the same method. I will use the same method. I'll show you how I use that method. So I'll just copy this one down. Okay, I'll paste it here. Okay, now I like to use this method of I want to actually find out, okay, what is going to be enthalpy of reaction. Okay, so here just put the arrow to form, to form, to form, to form. This one I know is 0. Why? Because to form the element of iron is going to be 0. Okay, now I have all the data. To form CO is negative 111. I need to form 3, so 3 times negative 111. To form CO2, so I need 3, so 3 times negative 394. To form Fe2O3, only 1 mole, so negative 822. Okay, so now, okay, I hope you understand. I think no need for me to write down a big circle. I think a small circle will do. Okay, this is actually over time you will actually learn how to apply. I don't even write it down. I'll just say clockwise is equals to anti-clockwise. Okay, so the clockwise is going to be 3 times negative 111. Okay, then clockwise plus negative 822. This is also clockwise plus enthalpy change of reaction equals to 3 times negative 394 plus 0. So you need to find enthalpy change of reaction. Please calculate.
Negative 27, sir.
Okay, good. Thanks. Okay, that's going to be the A. The answer is going to be A. So please make sure, okay, to select or learn, okay, learn which to apply which equation or which method that you want to choose, okay, when you encounter the problems. Okay, so I show you what this is. Question number 3 is similar to question number 4. Okay, let's actually see other questions. Now here you see they want you, okay, to calculate enthalpy change of formation, but they have given you combustion. Now for combustion, do not use the same method. Okay, don't use the same method when it comes to combustion. Okay, because okay, for combustion, I prefer to use the equation. It's much more faster, rearranging the equation. Okay, not just because of formation, I need to calculate. No, if you are given the formation data, okay, then it's going to be easier to use the previous method. But for this, okay, I will tell you what is the best method. Yeah, carbon plus oxygen is going to be carbon dioxide. It's given combustion. You just put negative 394. You write down the equation for combustion of hydrogen. Okay, so you are going to get water. Okay, 1 mole of hydrogen is burned. So this is going to be negative 286. And then write down the equation C4H10, okay, plus O2, carbon dioxide and water. Put 4, balance the equation, okay. So this one is going to be, I put 5, okay. Oxygen, I have 5 plus 8. 5 plus 8 is going to be, okay, 13, okay. So you have 13, I need 13, I put 13 over 2, okay. So this is going to be enthalpy change is going to be negative 2877. Now I will show you, okay. Here I need to get this equation, okay. I need to make sure, check, okay, what I need to have on my left hand side and right hand side and so on. According to the equations, carbon is on my left hand side. Yes, carbon is on my left hand side, is good, but you need 4, okay. You times everything by 4, okay. I need hydrogen on my left hand side. Hydrogen is on my left hand side, but I need 5. I times everything by 5. I need C4H10, but it is on my right hand side, okay. So what I need to do, change the equation, yeah, and it's still 1 mole, so change 4 CO2 plus 5 H2O gives me C4H10, okay, plus 13 over 2 O2. I am going to get plus 2877. The negative will become positive. So I can actually ignore this equation. So what I need to do, okay, even in the actual situation, I'm not going to even write everything. I'm just writing it to show you. It means basically if I add all this, I am going to get this. No need to worry anything. Yeah. So what you need to do, your work is to go and add all of this. Okay, please do that. So negative 394 times 4 plus 5 times negative 286. Then you add with 2877. That is going to be your answer. Someone help me to calculate.
Negative 129, sir.
Okay, very good. Okay, done. Okay, I'll try to share the screen again. It's quite laggy. Okay, I think my connection. Okay, number 6. Okay, let's actually go for number 6. Now, number 6, let's see. I think I will let you decide which method. Okay, Giuliano, can you tell me what method I will choose for this question?
The magic method.
The magic method, yeah. Okay, anyway, so this is formation method, probably the magic method, okay? So here you see you have all the data related to enthalpy change of formation, okay? So I will actually make it faster, right? So that we learn, yeah? So this one just put formation, 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 yeah? So this one to form negative 206. This one is 2 times negative 286. and this is going to be negative 808. I want the enthalpy change of reaction. Okay, so negative 206, okay, plus 2 times negative 286 all clockwise, okay, plus and enthalpy change of reaction equals to negative 808. Enthalpy change of reaction is negative 808 plus 206 plus 286 times 2. Okay, the negative will become positive. So you calculate. It's very easy. If you have the answer, just let me know. I will just circle and move to the next question.
D.
E.
Okay, for those who are still looking, yeah, I hope that I do not need to show you this anymore. Yeah, so please actually take note. The idea is you have your inside your mind there is a circle. Okay, somewhere below the here, and we are converting everything into curve surrounding that. Okay, so this one clockwise equals to anti-clockwise. Okay, so by later when you get pro, okay, you will be able to solve this kind of question in less than 1 minute. Okay, this is the expectation. Yeah, so you need to practice until you can actually see that question and solve within 1 minute. Yeah, now next they have given you some data. So what will be the best way? Yeah, so the magic methods, there are two. Let's say we say formation method, and there is another method which is rearranging the equation. So Sharon, which method will you use?
The arrow one.
Which arrow?
The formation method, not the
No,
combustion.
no, I think the for this question, yeah, I might be wrong. Okay, maybe you can actually do it in a different way. Okay, but the best method or the fastest method to do this is rearranging the equation. Okay, I'll tell you why. Okay, you see you are given two reactions. Okay, then you want to calculate the given reaction. So what you need to do, 2C. Okay, 2C is there. Okay, and then I want C2H2 on my right hand side. So what I need to do, I need to change the equation into, okay, to change this equation. So I'm going to get C2H4 to give me C2H2 plus H2. This is going to be delta H is going to be positive 175.8. And just now I just leave it as it is. So plus 2H2 C2H4, and then that's going to be delta H is going to be 52.2. So when I add these two equations, you will definitely get that. You have to trust me on this. Okay, no need to worry or have any doubts. Yeah, so but if you really want to see how this one and this one, when you add, it will cancel. Okay, and you will see that 2C, okay, plus H2, because this H2 when it comes over here is minus H2, you will get H2, and then left with C2H2. Okay, so this reaction is just, you just need to add 175.8 add with 52.2. That's it. That's the answer.
E, sir.
B or D?
Doc.
Doc. Okay. So please actually learn. Yeah. Basically the way, okay, that I'm showing, and every method that I mentioned in the video, okay, they are the same. And then I don't want to discuss the worksheet because I still want you guys to actually discuss within yourself. I still want you to try yourself. So that's why I went and looked for some questions. Okay, quickly I came up with this. Okay, so that we can actually learn. Yeah, Frederick, you can go to the toilet. Yeah. Now, so here I have another situation. Okay. Uh, here you see this is not formation, this is all combustion. Okay, combustion. and I'm looking for formation. Okay, formation of methanol. It means if let's say I want to write down, so methanol you write down as methanol is CH3OH. To form 1 mole of methanol, you get it from 1 mole of carbon, hydrogen. So how many hydrogen you need? You need 2. Okay, and then there is oxygen, so half oxygen. It means this is enthalpy change of formation. I need to calculate this. Okay, but you have all this data. Okay, now let me ask you, okay, given, is this going to be the formation method or is it going to be rearranging the equation method?
Rearranging.
Very good. Okay, this is rearranging the equation. Okay, so you see here, okay, carbon must be on my left. Carbon is on my left. I no need to do anything. Hydrogen, there's 2 hydrogen. I need to times everything by 2. So this one I need to times by 2. To form CH3OH, okay, so now, okay, I want 1 mole of that. So it means I need to change the equation. It will become plus 726. So you can actually erase that actually if you want. So I know that when I add all of this together, I am going to get this. Okay, trust me on this. Okay, it's going to be definitely going to be like that. So I just need to add all of this. Okay, that is going to be negative 394. Okay, plus 2 times negative 286. Okay, plus 726 is positive. So please calculate. So again, they don't want you to calculate. So let's actually see. Negative 394. Okay, plus negative this one times 2. And then plus. Okay, I need plus. The answer is C. Arwen, is that okay, everything? Can you understand, Arwen?
Sir,
Mm.
for the second equation,
Mm.
we times 2 because over 2, right, sir?
Yes. V times 2 because
What
the
about the third one?
hydrogen, okay? V times 2 because the hydrogen, there is 2 moles of hydrogen. So you must have 2 moles of hydrogen here. So in order to know that, you need to write down the enthalpy of formation equation. That is very important.
What about the third equation, sir? There's 3 over 2.
Which one?
The third equation,
The
for
third
oxygen has
equation.
3 over 2, sir. Yeah, for oxygen.
You mean the oxygen? You're talking about oxygen, is it?
No, we times 2.
I cannot understand. Which one?
The third equation for CH3OH plus 3 over 2 O, O2. Shall we times 2 everything since it's the fraction, sir?
Actually, no need. Okay, no need, because you see, I am rearranging all these equations. Okay, all these equations. Okay, it's not appearing over there. Yeah, all these equations are being arranged so that you can get this equation. Okay, it's not appearing over there. Just wait for a while. You want to actually do it so that you get this particular equation that I wrote in the, at the bottom, which is going to be this one. Yeah, you are trying to get this. Okay, it means we are using whatever that we have so that we get this 1 mole of CH3OH. So this is going to be 1 mole of CH3OH. You do not need to worry about oxygen, all this, because in the end, everything, when you rearrange the equation, you are going to get this. Can you understand, Frederick? Can you understand that, Frederick?
Yes, sir.
Yeah, like for example, if you are wondering, right? Of course, this is the first method we are trying to solve the thing, right? But now, if let's say you want to actually see what exactly happens, I can also show you. Okay, it's quite simple. I want to get this equation. Yeah, I want to get this equation. I rearrange everything based to this equation, the equation that I have at the bottom over here with the star, right? So I rearrange all the three equations that I have, okay, so that it matches my enthalpy change of formation. Yeah. So what happens when I rearrange everything times 2 and then rearrange? Imagine now I'm going to add, because since I'm adding these numbers, all these numbers, let's actually see what happens when I write the equations. Okay. So what happens when I write the equation? Hold on. Okay. So I will show you what. Okay, my connection is not so good. Okay, anyway, I'll still show you again. Okay, now let's actually write down, like for example, C plus O2, okay, to give you carbon dioxide, and then 2H2 plus 2 over 2 is going to be O2, 2H2O, and then CO2 plus 2H2O, CH3OH plus 1 over 2 is 3 over 2 O2. I'm going to actually add all this together. Okay, let's see whether we are getting this or not. Yeah, so here when I add, I know that carbon dioxide left and right will cancel. Okay, let's actually find out some things that I can cancel for sure. Yeah, left and right, this one is also cancelled. So here when I write down carbon plus 2H2 plus 2O2 gives me CH3OH plus 3 over 2O2. Okay, 2O2 means, okay, 2O2 means 4 over 2O2. Okay, so if I bring this over here, it's going to be C plus 2H2. 4 over 2 minus 3 over 2 is half O2, and you are going to get CH3OH, which is the same as this. So whatever that you do, okay, whenever you try to do the rearranging the method, you don't need to worry whether am I going to get this? No, if you follow the steps, you will definitely get that. Okay, so you just need to identify which method to use. That's it. Okay, you don't need to worry about some other things. Okay, as long that you know that, oh, I need to put 2 there, so must be 2 there, I need to times that 2, then you identify all that, you will not make any mistakes, trust me. Yeah, so Jasmine, can you understand this? Don't know whether you can hear me. Jasmine, can you understand me?
Yes, sir.
Okay, good. Okay, so let's actually move on. Okay, question number 9. Let's hear it from you guys. So Michelle V, what method we use over here?
The Mr. Gopi method.
Yeah, I have 2 methods. So which one? Rearranging or formation?
Formation?
No. Rearrange.
Oh,
okay, rearrange. It's much more faster, and then no need formation. The enthalpy of formations will be actually given. So I'll show you how you can do this very fast. There's 2, put 2 times everything by 2. Okay. On my right hand side, there's K2CO3. You flip this equation. Okay, so it means now I want, okay, I'll write down 2KCl plus H2O plus CO2 gives me K2CO3 plus 2HCl. Delta H is going to be positive 34. Okay, I just change negative to become positive. So what I need to do is just add these two, finish. Okay, 32.8 times 2 plus 34. You will get 65.6 plus 34. Okay, you will get 99.6. No need to think so much. Okay, if you're really good, you will be able to solve this within 10 seconds. Okay, so you just need to actually identify which method you need to use. Okay, Nathan, are you there? Cannot hear you. Nathan?
Sir, I don't understand how this works. Can you explain again?
Again, Christopher, you don't understand which part?
Like why
I times by 2?
flipped it?
Oh,
No,
why I
why
flip it and
what's
why I times
the
by 2,
equation
yeah?
I wrote in red?
Okay. So you see, yeah, again, whenever we do this kind of question, this is our final thing that we want to achieve. Yeah, the one that I put over there, that is what I want to achieve. These are my clues. Okay, if you want to put it over here, or puzzle, you want to actually rearrange the puzzles so that you reach here. In order, I'm just giving you a trick how to rearrange so that you can fix the puzzle properly, or you can solve the puzzle properly. So what you need to identify is you need to make sure that this KHCO3 is on your left hand side. So I know that this is on my left hand side. It's okay, fine, good. Okay, good. But I need 2 moles. I need to make sure everything is times by 2. Okay, that's why it's going to be times by 2. Yeah. Then in this particular reference, I know that K2CO3 is on my right hand side. When I see this puzzle, it doesn't match. It's actually on my left hand side. I need to flip the equation. Okay, inverse the equation. And then see whether I need to times anything or not. 1 mole, no need to times anything. I just need to flip. So I just take the entire thing, okay, and then I just flip, okay, and then what I did was negative 34 will become positive 34. That's it.
Wait.
Yeah.
Why again?
So you
why did you flip it?
Because, okay, I want to make sure my K2CO3 is on my right hand side of the equation. Because here they are in the reactant part. I need to make sure that this one becomes product. So you need to flip it. The same thing as the previous questions and so on. So why I flipped this earlier, okay? Because I want to achieve all this, okay? I want to achieve all this. So here, the CH3OH is on my reactant part. I want the CH3OH to be in my product part. So that's why this is the product. So I need to put it invert. Can you understand, Christopher?
Yeah.
Yeah. So this is the technique for the playing around or rearranging the equation. Yeah. So let's move on. Okay, question number 10. Let's see whether you guys can get it or not. Okay, Megan, what method do we use?
Rearranging the equation.
Very good. So you see here, this is our, okay, this is the one that I just put in the box over there. That is what I want to achieve. These are the clues. Okay, so using the clues, okay, you see this is going to be SO2 on my left hand side. I need to flip, okay, and then I need to times everything by 2. Why? Because 2 moles. Okay, so write down. Okay, normally next time you no need to write down when you are very good at it. Okay, but this one I write down. This one will become plus 296.5 times 2. And then I know the SO3 is on my right hand side, so it's good enough. 2 SO3 some more, no need to do anything. So you just write down negative 791.4 Now just add these two. That's it.
Sir, for this method, like, does this apply to all equations or
no? There's only
then which equations?
okay.
How do we know this applies to an equation?
You can see from the way the question is being asked. Like for example, as long you don't have formation is given to you, okay, it means all the data about formation is not given to you. Definitely, this is going to be rearranging the equation, okay, and there is more than one method that can be used to solve this question. Yeah, but I'm just giving you this method where you can there's only two methods that I want you to focus. One is the formation method. The second one is the rearranging the method, rearranging the equation. So now I'm just teaching you, the moment you see the question, which one do we choose? Okay, that's why I'm actually training you, which one do we choose? Okay, so you see the one that actually involves the formation, the question, it looks like this. They will give you all the formation. Okay, then it's much more better if you can actually use this method. Combustion, all the combustion is given, but it's slightly similar to the way that they ask for this. But I told you, don't use the formation because it's not formation. So you use rearranging method, but you still need to write the equation. So I hope you can roughly, if you want me to come up with a method or when do I use this, I can tell you most of the time, if the data involving combustion is given, then most likely is rearranging equations. If the most of the time there is a lot of data on formation is given, please use formation method. But I don't want you to follow that, it's like fixed. It's going to be like that. No, you need to be able to predict which method that will be suitable for a certain situation. So there is no fixed method. Okay, you need to actually, like for example, okay, when you see this question, let's actually finish this. Number 10, what is the answer? Negative what?
Sir, for number 9.
Yep.
Why is H2 and CO2 ignored?
Oh, because it's going to be why what? CO2 and H2O is ignored because they will actually get, you see, again, like what I said earlier, when you rearrange the equation, okay, these two equations, what is going to happen is you are going to come back to here. It's not going to be ignored, okay? It's just going to be, I am using something that is, how to say, like if I use H2O and CO2 as a determination to actually see which one I'm going to choose, you will have like, why I don't actually use H2O left and right? This is right. But the reason is simply because both of them have H2O. How do you know which one? Okay, like if CO2, both of them also have CO2, but I choose this one and this one to identify the rearranging because there's only this in this particular equation. There's only this compound in this particular equation. So I know what, if I make adjustment according to that, I will definitely get the answer. Something like that. I hope it answers your question. That's the reason why I don't even bother about H2O and CO2. I see something that is obvious. Okay, like when you solve a puzzle, of course you can actually see everything inside the puzzle, but the thing that is obvious is how this thing is going to fix to the other puzzle. Okay, so you need to actually figure out this, and this thing is this one. That's going to actually match. So we need to learn. Yeah, we need to learn about this, how to identify. Okay, so here, okay, anyone calculated already? Number 10? Negative what?
Negative 198.4.
Okay. Have a look at number 12. This one. So let's Christopher decide now. Christopher, which method?
The
formation method or
forgot the name
rearranging?
already. The formation method.
Yes. Okay. There's a lot of formations. Okay. So we will use formation method. Put the arrow. Put the arrow. Okay. So this one is going to be negative 3012. Formation of water 6 times negative 286. Formation of this 4 times negative 1279. 4 moles. Yeah. So here you put the circle over there. Clockwise equals to anti-clockwise. Negative 30. Okay. Negative 3012 plus 6 times negative 286 plus enthalpy change of reaction, what I want to find, okay, equals to anti-clockwise 4 times negative 1279. So you just need to calculate the enthalpy change of reaction. Someone help me to calculate.
Negative 388.
Okay. So if you follow this, okay, if your answer is negative 388, that's going to be the answer. Do remember this. When I collected all these questions, I actually collected today only. Okay. I took 10 years or at least 11 years of your paper one. All these questions are from paper one. Okay. From your past year papers. So it means everything that you see now is all asked in the actual situation. And we are just learning which method to apply accordingly. That's it. Yeah. So let's actually move on. I think this is the last, I think I have 14 questions, 14 or 15. Yeah. So anyway, but I just want to, this is similar. Yeah. 13. You see all the formation. Okay. So just put, okay, 2 times 50.6. This is going to be 9.2. This is going to be 0. Okay. Element. This is going to be 4 times negative 241.8. So 2 times 50.6 plus 9.2 plus enthalpy change of reaction equals to 0 plus 4 times negative 241.8. Enthalpy change of reaction equals to, someone help to calculate. So if you have done, just let me know the answer. Okay. Now, what do you have after this? Is it dismissal?
Life skills.
Life skill. Okay. I think this one you can actually do yourself. Yeah. They burn something. Okay. They heat. I think this is quite easy. What is the experimental value of the enthalpy change of combustion of propanol that can be calculated? Okay. Please use Q equals to MC delta T. Okay. And then the mass. Okay. The mass, you use the 100 gram of water. Okay. So you find the Q. After you find the Q, you relate to this 0.025. Try to find for 1 mole. Yeah, try to find for 1 mole.
The unit of mass is gram or kilogram?
Gram. Always in gram for chemistry. Okay, for physics, it's going to be kilogram. For ours, it's always the mass for any of this calculation, even moles and this equation. They have rearranged the C so that you use gram. So the C is always 4.18. Okay, so this one is going to be gram. This one you no need to convert into Kelvin because you just want to find the temperature difference. Okay, and then the final unit is joule. Okay, for this. Then here you must be very careful because they give you in kilojoule. Yeah, so that one you can do. Now this one probably next lesson I will actually discuss with you. This is slightly different because this one has to do with bond breaking and bond formation. This one is the only clue that I can give you how to solve this. Yeah, bond breaking and bond formation. And then when you have that, okay, the enthalpy change of combustion is bond breaking. Bond breaking is always going to be positive. Bond formation is always negative. So whatever value that you have here, plus with whatever value that you have over here, it will give you this. So whatever information that you want to find, you can find out from this relationship. Okay, so I will actually teach you tomorrow. Okay, but today's lesson, yeah, I really wanted you guys to actually see when do you use the two methods. Okay, I think no need to actually refer Mr. Gopi's magic method or something. I think the two methods that I want you to remember is rearranging the equation and formation method. Yeah, these are the two methods. So please actually learn how to apply this. You still need to submit the worksheet that you're supposed to do, yeah, for this. Yeah, please discuss. If you need to discuss with your friends, please make arrangement, discuss, and submit to me by Monday. Is there any question you want to ask before I end?
Sir, can you go to number 1?
Okay, number 1. Okay.
How to know that the mass 50?
25 cm plus 25 cm. So both of them are aqueous. So when the energy is being transferred, that energy is being transferred to all the water. So 25 cm3, here also got water, here also got water, then 50. So 1 cm cube is 1 gram. 1 cm cube is 1 gram. Please remember this. Does it answer your question? I think we are already late. Okay, thank you guys. Okay, if you have further question, you can actually WhatsApp me. I will reply you. Okay, see you. Bye.
Bye, sir.
Yes, sir.
Yes, sir.
Yes, sir.